don't overcomplicate, don't overthink. Sometimes the 80% you already have in place will do the job.
This is DevOps Paradox, episode number 324. Kubernetes resource right-sizing and scaling with Zesty. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Recently, Kubernetes 1.34 was released. At the time of recording, it was really recently released, as in a few hours ago. And it still seems like it's yet another boring release. What do you think, Victor?
Kubernetes is boring. It is a boring release. That's a good thing. It was not boring first 5 years when every release would be earth-shattering change with new features that people were desperately missing and so on and so forth. Right now, it's stable. It's used by almost everybody. It's been around for 10 years. People are more focused on making it continue being stable and working than changing everything.
But the workloads have changed over time.
Like?
Can I say it?
Yeah.
AI workloads have been introduced. Is that going to keep things stable? On today's show, we have Omer Hammerman on from Zesty. Omer, how are you doing?
Hi, good. How are you? Thank you for having me.
What do you think about that statement? Kubernetes is plain, boring, 10 years in, everything's great, but yet now we have workloads that could potentially upend all of that.
I have these two figures on my shoulders screaming counter arguments. One of them is saying boring is good when you're going to production. That's what you want. On the other hand, Kubernetes isn't that boring because it takes the boring old workloads and shifts them into the dynamic world of pods getting up and down. You can run temporary jobs, you can basically do anything. And while the recent release is kind of boring, the one before that, to those of us who have been working with Kubernetes for quite a while, there have been some exciting changes. And it's going to be a very nerdy, exciting change, but 133 was one of the most exciting releases with a very special feature that I've seen. Bottom line, boring is good.
But what do you think about AI workloads potentially upending that stability?
It's definitely pushing the limits of what the system can do, but it's not getting there. So there are a few aspects, and AI is it's another type of workload, but not something we haven't seen, because we're not talking about whatever's going on inside the container. It's just a new type of workload. Sure, it requires a lot more. It needs more CPU, preferably GPUs. It needs a lot of disk space. You probably do want to put more gateways and firewalls and cover it with more layers of security. But at the end of the day, you're just running another type of workload, which I'm happy that Kubernetes has been around for that long, because we've kind of prepared ourselves, well, not us, whoever's working on the code base, has been preparing the world for something stable enough to run AI workloads on. So I'm happy with how things are.
Well, you're speaking as a technical person. If I was the business person and I'm having to add disk, I'm having to add GPU, I'm having to add, what was now costing me maybe a few million a year is now costing me 5x, 10x that.
That cost is not in Kubernetes, right? That cost is outside and independent of Kubernetes, right? You just said GPUs, right? That's the cost. Not that you got new workload in Kubernetes.
Exactly. I'd actually claim that the fact that you can run this in Kubernetes is something that helps you reduce those costs. Because if we didn't have Kubernetes, you'd have to, like Victor said, it's just something that you provision in whatever cloud provider you use, and you just launch your workload on there. But having Kubernetes, meaning the keyword here is auto-scaling. You can scale up when you need the load, and you can scale down. And that goes to everything with a few stars here and there. You can scale down pods. You can reduce the size of the nodes. You can even reduce the size of volumes. That's a comment for later. But you can basically resize everything. So having the ability to resize and automatically scale things works in your favor. You can use it when you need it. By the way, cloud resources are, quote, air quotes, infinitely scalable. You can expand them forever, and then you can shrink them. And that's the fun about paying on demand and paying as you go. So it works in your favor. That's what I think.
I guess that's okay.
What's okay? That you can actually spend less money on GPUs than you would normally spend.
Okay. People that have listened to the show know that I'm not anti-cloud, but I'm also a strong proponent of data centers. And that's sunk cost. And I'm not going to be able to scale that down or reallocate that.
By the way, how are you going to buy GPUs for your data center?
I have an in. I have a back door.
Here's the thing. You're right that it's sunk cost. And when you have your own infrastructure, maybe just part of it, but if you have your own infrastructure and it's bought and it's installed in a data center, the moment you allocate everything towards one goal, it's allocated. Doesn't matter if you use it or not, you've already paid for it. However, if you're using something like Kubernetes, you might be able to resize things dynamically to free up resources on the side. It doesn't mean you're not going to pay for them, but it does mean you can reallocate them towards other efforts. This is especially important in large enterprises and in larger teams that have multiple products, multiple divisions, multiple efforts going on. So if you can free up resources, it works in your benefit. And yes, you're not going to pay less in that sense, but you are going to be able to use it. And more often than not, you've already paid less by the fact that you went to a data center rather than a cloud provider. So I think you made it.
With your own data center, it's not that you can pay less. You can avoid buying more.
Exactly. That's better wording. Yeah, I agree.
Okay, I'm just trying to push on this AI thing because people are getting all up in arms over, oh, it's AI. It's like, look, it's another workload. It's sunk cost. Even if it's not sunk cost, it is going to be an ongoing cost that you're needing to have. And I'm air quoting needing here very hard. Are people wasting money today in AI workloads just like they were wasting money back in the early days of Kubernetes? And they're either going one of two things. They're either wasting way too much money or they're optimizing too soon.
Most likely. And this is my argument against your own data center, right? We don't really know, companies do not really know yet what they need. They have no idea. Should they create their own models? Probably not. Maybe yes. Who knows? There are so many things that are completely unknown. People will tell you on YouTube or television or whatever, we know stuff. Nobody knows stuff. And nobody knows what's going on, right? And even fewer people know what will be happening half a year from now. And that means that actually investment in your own hardware for the things you don't know, and you don't, as an enterprise, like a bank traditional, you have no idea what to do nor what will be happening in the near future. So the only thing you can do is actually say, okay, let's just experiment. And let's experiment by leasing what we need instead of buying.
I agree 100%. I mean, you can pick that path, but if you look at, let's take a look at, again, air quotes, influencers. You have a guy like DHH running 37 Signals. He's one of the biggest pushers of move away from the cloud towards your own data center, which is great. But not only he's famous enough to get whatever people he wants, he can literally hire anyone. He just posts something on Twitter and he has like 1,500 CVs coming in the same second. So that's one. And two, he had his company for like 20 years. It's a stable product. They know what they're doing. Even though if they're slowly progressing towards AI, it's a slow move. So they can anticipate what's going on. They can forecast how much resources they need. But like Victor said, we're not all DHH. Most of us aren't. Companies, even banks that are now digital banks, and the recent ones that have maybe started in the past decade, they literally don't know what's going on. And I think Victor said 6 months. I think most people don't know what's going to happen next month. I mean, the pace of AI releases is something our minds cannot comprehend, not at this pace. So in that sense, having something that can grow and shrink is amazing. Shifting back to the Kubernetes world, if I could have one suggestion to anyone listening, running on Kubernetes, going into AI, is invest a lot more in your auto-scaling capabilities, meaning having automation around what's scaling both up and down. Be able to resize, right size, of course, right size everything, make sure that everything is efficient as it can be, but also be able to grow and shrink as things move.
You were talking about a feature in 133 that really caught your eye, but you didn't tell us what it was.
You're right. So 133 had released a very special feature, which had been in alpha, which means alpha version in Kubernetes don't get released to the major cloud providers basically never until it goes to, I think, either beta or GA, I don't remember. This feature, it's called, I don't remember the official name, I think it's in place resource update or something like that. It basically means that you can take a pod and change its resources, CPU allocation or memory allocation, and having it change it on the fly without restarting the pod, which is crazy. People wanted it since ever. There have been some really huge challenges with it because it basically goes to the core of how namespaces work in Linux. And it's been just moved to beta in 133, and then it was released. And it's not the end of the story because you literally have to change specific pods now. You cannot go to a deployment or a stateful set and update it there. That would require a recycle of all the pods and updates of everything. But this actually connects beautifully to auto-scaling and right-sizing things, because this means you can now go through your pods, whether with a script you wrote or a controller in an operator you built, look at the pods, naturally monitor how much they're using, how much they have been using, statistically going backwards, and then update them on the fly, changing them within the node. It's not a guarantee that they will get changed. Naturally, they're running on hosts. Maybe there's not enough space, there's not enough CPU or memory, but they will get updated in place if that's possible without causing any interruption to your system. That's the feature.
I forgot actually that. Actually, didn't forget. I'm always waiting for GA because Kubernetes now changed the rules. I think that it's available in Kubernetes after GA. But anyways, that's very exciting because that finally makes vertical scaling actually useful. Now, we're still missing, or maybe I'm wrong, so correct me. You probably know much more about it than me. Does that mean that we are going to move towards finally having vertical and horizontal scaling working together?
Somehow I find myself in the same conversation every day. I don't know why. So this is actually super exciting because yes, I do think that's the direction. Now, Kubernetes has this concept of, they call it multidimensional autoscaling, meaning you can go horizontally or vertically based on this air quotes brain that makes the decision on the fly automatically. You don't have such a thing, right? We have the HPA, which is an open source. You can install, most companies install it. And then you have the VPA, but it has this huge warning on it that says you cannot use VPA with HPA using the same metric on the same resource, because it will just create a negative feedback loop. So I definitely think that it's going towards that. Now, back to the concept, multidimensional autoscaler is just a concept. Kubernetes, they love this thing. They put out a concept. They will literally tell you how to build it. They won't build it themselves. I don't know why. They leave some things to the cloud provider, like container, what do they call it? The CSI, for example. It's a concept. The cloud providers have to implement it, or whatever, whoever you are. It doesn't mean that you have to be a cloud provider. That was a long answer to say, yes, I definitely think that's the direction.
I hear horizontal. I hear vertical. Therefore, I hear X. I hear Y. But where's the Z?
Z is in time?
In time. Or not time. What is Z? Because if we're going to be living in a two-dimensional world in Kubernetes, then I don't have great hope for it over the decades.
Z is already, correct me if I'm wrong, right? But Z is already there together with X, assuming that X is horizontal for a while, right? Nothing prevents you from saying, okay, the criteria for scaling will be based on the metrics that are gathered over a month or anything, right? I can look into Prometheus, create a query, and define threshold that will scale it horizontally. And that query can be based on, not can, but must be based on a period of time, right? Whether that's last 5 seconds or last 5 months, it's fully up to you, right? The problem is that graph that you are visually narrating doesn't have why. Yes, why?
What if we assume that Z is in fact a T, a time period?
Yeah,
and
time, yeah.
With that analogy, I think, Victor, what you mentioned is exactly that, right? Because, for example, the feature of in-place right-sizing shortens the time to my goal. My goal is to right-size things, is to auto-scale things. If that basically does it in 0 time. The time we count in Kubernetes is usually the downtime, right? I'm trying to make a change, and then that means something is getting replaced. There's some interruption in the system, or I'm provisioning something new. A new stateful set, a new deployment, a new pod, and there's time to launch it until it serves a healthy health check. So this allows us to shorten the amount of time required to replace those things. And if we're talking about autoscaling, there's autoscaling out, there's autoscaling up and down, which means making the same thing larger, right-sizing vertically. These things take time because new pods take time to either update or restart or whatever. The more we get closer to in-place changes, the more we can shorten that third dimension. So that's actually something that you just brought up that came up to mind, but I think that would be perfect if we manage to get everything around that. 0 time.
If we're able to reach this nirvana to where everything is magically up, down, wide, not wide, do I even need to worry about requests and limits anymore on a pod?
I think just like nirvana is in Buddhism, you'll never actually get there. It's just a concept. There's no way to reach that, right? Because to the point of in-place right-sizing, there's limitations. You're going towards the limitation of the host or a node. And if that's not yours and you're using a serverless, air quotes, solution, there's limitations to the underlying platform. And if there's no limitations to that, there's one thing I'm sure everyone will agree on, there's limitations to your monthly bill. So at some point, you're going to hit a wall.
Depends what you meant, Darin. By worrying, did you mean worry how much memory I should assign, or worried about available?
Or do I need to assign anything at all? Because, even coming up with those first numbers correctly just seems like a waste of time.
This is going to be radical, but the thing that there is a collective hallucination going on in our industry. By you thinking that you know how much memory and CPU something needs. You have no bloody idea. You don't know it on day 1, you don't know it on day 2, you don't know it 3 years later. To me, I think actually that's one of the mistakes, in a way, of Kubernetes. Teaching you somehow that you should specify how much memory and CPU something needs, while you have no idea. At best, if you're very experienced, you have approximate guess, it's Java, probably 4 gigabytes. And if it's Go, then let's say 1 gigabyte of memory. Because, it's not Java. That's how it works.
I'm laughing because I have a day job that's around. The reason I have a job is because I'm trying to answer this exact question and doing that dynamically over time in Kubernetes automatically. I totally agree with your assumption. The fact that we're letting users decide something, not only letting them decide that they don't know, there's no way for you to learn about something that did not pre-exist. Not only that, again, air quotes, you cannot change it. If you change it, it dies and restarts itself. That's a great point. And by the way, it's not all about CPU and memory. Mind you, there's another aspect of things, especially when we're talking about AI in Kubernetes, which is storage. Now, storage, especially if you connect it to a cloud provider, like we talked earlier, it can grow. You have to turn on a switch that's called auto expand or auto expansion or something. You have to turn that on. And then if you've provisioned 10 gigs and you now need 100, it will go to AWS, GCP, or Azure, or whatever you're using, and we'll tell that, please add more. And under the hood, it'll add a bunch of more disks, but you'll get the same thing. The moment you want to scale it down, won't work. That's another thing I was and still am working on solving. Just another dimension, maybe, to consider.
It's all about dimensionality, I guess, is what we're saying. Because even if you did know, you had observed, you knew how to set the values. That's true until the next spike or the next update of the app, which changes the memory profile, it changes the CPU profile, it changes something. So what was true an hour ago may no longer be true.
Which is exactly why you have to build automation around it. Making those decisions based on let's call it a cron schedule will not always work. Sometimes it's okay. If you're making, like you said, if you're making application adjustments that are now requiring a bit more memory, if it's just a bit and it's growing over time, the next cycle of, let's say, 7 days from now, someone, a human, would literally go check out the Grafana graphs or whatever you're using, and based on that, make decisions and update the workloads. Fine, it would work to some extent. However, with the spiky workload we live in, it won't work. The only thing that will work, especially in downtimes, we have to sleep sometimes, you have to create an automation around it. If you have something, an operator, a script, whatever that is, that runs constantly in the cluster and measuring what the applications are doing, and based on that updates the workload, especially using the new feature that can do that without even replacing them, that's how you win. I don't see any other way.
My concern in that is measurements are still probably all that we have. We're looking at disk I/O, we're looking at CPU utilization, we're looking at memory utilization, but those values are too static. And even if you were able to respond quick enough, is it even good enough?
I'm guessing if I'm reading between the lines, you're saying we don't have enough context, which begs the question, if we have had eyes inside the container to what the application is doing, like Victor mentioned Java. So if I could see the JVM and its configurations, or if I could see the node process, or if I could see whatever the application is doing, then I would have a bigger context window and then use that. And it's a good question. I don't think I have an answer, but maybe that's part of the world we're going to. You'd have to have more context.
Victor, what do you think about that? Is it all AI nowadays? Is that what we're headed towards?
AI for sure. That's probably, we can have a long discussion how useless or useful AI is. But one thing that I'm surely convinced that at this point AI is pretty good at crunching data. It might be good or bad at giving you suggestion, kind of, hey, write this line of code or do this or do that. That can be a discussion, but crunching data is definitely better than us. So it mostly depends on how well we can explain it to AI what to do with that data. Or maybe not explain it, but have some automation behind it or what's or not, right? But crunching data, yeah, definitely. Because when you think about it, we are doing, at least in the past, we were doing some relatively unreliable things. And that's, hey, I'm going to write a query for Prometheus, and that query will say, okay, what is the average memory utilization over past 15 minutes? And if that is above 80% of what I specified there, and what I specified there is completely random, by the way. So if last 15 minutes of memory utilization is above 80% of the random number that we put, then you scale up, right? Or vertically or horizontally, whatever, right? It's pretty unreliable way to do it. And we cannot really, it's very hard for us, at least for me as a person, to write really a comprehensive query, kind of, I will write a 500 lines query that will actually take into account and both short-term and long-term memory usage and spikes and all this stuff. It's close to impossible, right? For me as a person to write that. So I need to stick with last 15 minutes or whatever the period of time was the average, right? That's as far as I can go. And I would be very surprised that AI cannot improve it. Even if it's 10%, it's better, right?
So what you're suggesting is that AI improves the infrastructure on which AI runs, But then in turn, the new AI that improves it would need more infrastructure because it would need more resources.
I was not necessarily now talking about scaling of AI workloads, but scaling in general. But yes, including itself.
We're poking at AI. That's just what it is that we have to do in 2025. If I was a startup today, and again, I was thinking, what would I do in the next 5 years? Okay, a startup doesn't have 5 years. A startup has maybe 5 months. What would you prioritize at this point?
Can I answer that? Can I please? Are you a startup funded by VC money?
Yes.
You will not get money if you're not doing AI something. Doesn't matter how silly that idea is. Doesn't matter how useless that something is. You will not get finances. You will not get money for your startup if you're not inventing something ridiculous related to AI.
All you have to do is add -AI to the name. That's
Exactly. Buy a domain.ai.
Yeah.
Okay. That's enough of that. What would you prioritize though? I mean, okay, let's bring it back out like 2 years, 1 year, 2 year. What are you going to prioritize? Because in this world now, at least that came in 133, knowing that I can right size a pod as long as I've got enough resources on the host, correct?
Yes.
So if I can do that in place, it seems like now I'm not chasing after the smallest or at what point do I stop over optimizing and just take a good, air quote, size machine host to run my workloads on? I mean, how do I even start? Because we were talking about optimizing pods, but now it's like, okay, well, what I really need to do is optimize the machines those pods are running on. However, I've just pushed it out a little bit further.
I think that's just another layer of the same system. When I speak about auto-scaling, at least, I'm always considering the nodes underneath because it's just part of the system. Pods are analogous to boxes. If you want more boxes in the same crate, the crate needs to be not bigger, but it needs to hold a number of these boxes. And you need to play with the numbers in order for the boxes to fit. If there are 2 boxes and one is a little bit too big to hold 2 of them on the same machine, but still the machine is large enough to hold one, then you're wasting space. So there needs to be another statistical game here, deciding which are the perfect nodes, not just in size, but also, instances can be memory intense. They can be geared towards CPU. They can be geared towards GPUs. Would they come with NVIDIA or whatever other cards you can put on them? Another part of that automation is not only learning what kind of instances you need, what are the sizes you need, and changing them over time. There are platforms for that. There are tools for that, like Carpenter or the Cluster Autoscaler that most companies have, and using that to decide what nodes am I going to use. And over time, you started by saying, when do I stop over-optimizing? Which I think the word specifically over-optimizing probably suggests that it's something negative. You don't want to over-optimize. That means you've spent too much time doing something that you probably shouldn't. But when do you stop optimizing? I think pretty much never. It doesn't mean that you as a person or as an engineer have to physically go and manually make changes, but it does mean you want to have something that does it for you. And this leads me to your even previous question about a new startup. What do I invest in? And that's naturally my own opinion. Outsource as much as you can. If you're a new startup working, especially in the AI field, you don't want to mess with auto-scaling and expand or shrink volumes or right-size your pods. That's my take on it. You can use the open source tooling that you have. That's great. But you have to have someone not only install them, maintain them, make sure it works properly. And it doesn't take you all the way. Like we mentioned, you won't right-size the way you think it will. That's my take.
So let me go ahead and bring the storyline back to DHH for just a minute. So what you just said was, if I'm a new startup, I don't want to run Kubernetes myself. Let's put it that way. I don't want to run it myself. I just want something to run whatever my app is. Then over time, I might want to run my own thing because the other thing is costing me more money. And then if by the grace of God, we make beyond 5 years, then we might start thinking about pulling it back into our own data center.
I want to push back on that cost more money. I don't believe that cloud costs more money. Very often it doesn't. But it does cost more money if you compare only hardware with hardware. And you say, okay, so I have 100 servers that I bought, and 100 servers in AWS cost me this much. And you're completely ignoring that you will be, first of all, paying sometimes 50, sometimes 100, because that's the maximum. And more importantly, you're ignoring people. What is the average expense for a person? Like 200K a year, 300K a year, with all the expenses higher, right? And usually companies ignore that. It's kind of, okay, it's a server costs this much here and that much there. The fact that I need to hire 20 more people just to manage my own data center, that is somehow not the cost.
And also, as a new startup, good luck finding someone that doesn't want to work in the cloud and does want to run on a data center, which sounds archaic and something that most of his friends want to have Kubernetes and AWS in their CV, not working in the basement in a data center.
Oh, you just hit a point that ticks me off. Let's stay here for just a minute. CV-driven development. Come on, people. This has to stop. Will it ever stop?
It's not only CV. Let's say that you're a cook. Would you choose to? You would say like, oh, it doesn't matter. I can work on in a truck, right, food truck, or I can work in a restaurant. Doesn't matter to you at all? Of course it does. It's not only CV something. It's that I want to work in a good company, a company that will help me grow my skills. And yes, those skills eventually go into my CV. Of course it does. But it's very natural that you don't want to work in a food truck and you want to work in a proper restaurant, right? If you would be a cook.
It's even worse in tech because the game is rigged against you. Now, I'd be the first one saying, ignore the CV, do what you like, do where your passion is. But if you want to work at a better company later, the game is built in a way that people have, LinkedIn is built that way. They have automation that will scan keywords in your profile to learn whether you're a potential match as a candidate for a company. There is no way around it. So if that's your goal, if that's where you want to be, if you want to move laterally or gradually towards larger, bigger, more famous names, there's no way around it. Doesn't mean you have to ignore all options that don't include the cloud or Kubernetes or I don't know what's the next hype. But it does mean you have to consider it.
You sound defeated, Darin.
Yeah.
Come on.
I will
put up a fight.
What I will concede is that it's fine to put things on your CV. My problem is the job hoppers that are, okay, I spent 2 months on this. I got it on my CV and now I'm going somewhere else. And okay, maybe not 2 months, but maybe just a year. And my concern with that is these are the people that are going to be running the infrastructure for decades to come, unless they happen to go work at Meta or something to where they get a 100 million, 200 million signing bonus paid out over 5 years. I don't know where this is going. And especially, again, throwing AI back in there. Now we've got C-levels. Hey, let's fire everybody. Let's just replace it with AI automation and everything will be fine.
I have to say something I believe in life, and it doesn't have to do with tech only. It's everything. Regardless of whatever happens, there will always be demand for quality, right? If the people in the next 5 or 10 years are going to be the people that after 2 months with Kubernetes decided they're expert, no one is an expert in Kubernetes. No one is an expert. Even the founders, there were 4 core founders. One of them is an expert in API machinery. He has no idea how storage and scheduling works. So what I'm saying is if these are the people, the ones that work 2 months with a new technology and now they're experts, and these will be the ones that build the infrastructure, at some point it will break or get breached. Something will happen, and then they'll find whatever. They will go find counseling. They'll need the advisors. They'll find the professional, the high quality, the name that they know they can trust.
So what you're saying is we're actually living in Jurassic Park and life will find a way.
Absolutely. 100%. I stand behind that.
Survival is not optional. Is optional.
Just don't go to the toilet out in the woods when there's a T-Rex there, because that's a bad thing to do.
Yeah.
I'm trying to figure out, okay, so I want to go back to the memory and CPU thing for a second, because it got a little too dark. What else do we need to be tracking besides memory and CPU? I mean, those are the basics. I mean, it seems like we always should start there. But the key word there is start. There has to be more in order to understand, especially breaking out this 133 feature, because none of us can remember the name of it. And even if we did, it'd probably be too long to say. So we're saying the 133 feature. What are the other things that we really need to know? I mean, it seems like, sure, if I've got space and I can vertically scale it, I'll take that. Right? That's a good thing.
Here's a question I have. Does all that mean the vertical scaling now without restarts, without relocation of pods, or whatever it's called, that assumes that actually we don't have right sizing in a way, right? Because imagine in an ideal world where actually my pods are right sized and my nodes are right sized and there is very little waste, right? Ideal situation. Close to no waste. That means that my changes to memory CPU that do not require pod restarts will never work. I know it's a world that doesn't exist, but in an ideal world, I cannot change memory and CPU, at least cannot increase it without restart, even if that feature exists.
Yeah, which means you need to right size the other layer. But I want to say, so I want to pull a thread for a second from that question to a previous question we didn't deal with, which was, it would sound strange, but bear with me. We asked the question whether new companies even have to deal with Kubernetes or use managed Kubernetes or whatever. What I want to say is, sometimes we overthink things and overcomplicate things. It doesn't mean, I work at a company, that's all I do all day, right? I build right-sizing features for everything, especially in Kubernetes. That's what I do. But sometimes we overcomplicate things. New companies tend to jump on Kubernetes because of FOMO. The fear of missing out something, the fear of missing new technology connects back to the CV-driven development or hiring or whatever you want to call it. Back to the resources part, CPU and memory are great. They're the main two metrics to look at. You can use additional context. You don't always have to. Putting that aside, more context is hard to get. You definitely have to consider it. If your application doesn't need to scale based on CPU and memory, but based on a length of a queue or another application-based metric, you can use things like CADA, the open source layer that helps you do that. So we'll find your horizontal autoscaler and help that autoscale based on other metrics. Again, back to the startup world. I won't invest so much energy and time figuring that out and fine-tuning things if they don't correlate directly to what I do and pushing me forward. I made a complicated argument here, but I hope the message got through.
I'm trying to figure out what the message was. I actually got lost.
Don't overcomplicate, don't overthink. Sometimes the 80% you already have in place will do the job.
Okay. That's a nice bow on top. Thank you. That helps. And I did take offense at that we overcomplicate things. We're in tech. We don't overcomplicate things. It's just what's necessary. That's a joke, by the way.
If you had comments on here, people would say that exactly what Kubernetes is. That's all it is. Complication of technology. It's not what I think.
I strongly, whenever I hear those comments, I go into offensive mode. I dare anybody to show me a less complicated, easier way to do what Kubernetes does. You might not need it.
Ooh,
that's
the point, yeah.
That's a different thing. Do you need that? Maybe you don't. But there is no easier or simpler or less complex way to do what Kubernetes does. Doesn't exist. Sorry, it does exist, but I'm excluding now special services like Google Cloud Run, and it exists as a service, yes, but something you can do doesn't exist.
You know what? I'll bite. I think there are simpler frameworks and systems, but, and that's a big but, if you need, it's not the complexity, if you need the features and the community and the ecosystem that Kubernetes suggests, provides, if you ever looked at the CNCF landscape, that would tell you enough of how the ecosystem is broad. If you don't need a lot of that, and some companies don't need, I love ECS on AWS, especially on Fargate. It's so simple. Everything's connected. If I have two applications that need two replicas, that's the first place I'd go. So simple. No need to instantiate anything. Just works, connected to CloudWatch. Everything's beautiful. The moment you need a complication or something that Kubernetes knows how to do, that would be the first pain. And that would be the first signal. But like you said, not everyone needs it.
Yeah, exactly. But if you do need it, like I can easily argue that I can come up without thinking with 5 things that ECS doesn't do, Kubernetes does. And you can probably do it in ECS, but then you will start jumping into really more complication than with Kubernetes.
Absolutely. 100%.
What are some of the common mistakes people are doing today when they're just trying to get started in right sizing? Let's simplify it a bit. Like they're just trying to get started. What are the handful of things that everybody gets wrong?
I think the first easiest one is just not doing it, not being aware of your options. Most companies, I think, tend to go with horizontal scaling, which is more understandable, and they seem to not trust the vertical scaling. For a good reason, more interruptive, more risk to the process. But sometimes you'd actually benefit more than having VPA operating in your cluster. So what I'm saying is basically, if I need to wrap everything to one line, have the information first, learn about the capabilities, and then make a decision. Too often I see companies literally not knowing about the options and just doing something, by the way, because an LLM said so. They logged into ChatGPT or Claude and asked it to help them auto-scale Kubernetes. So they use the output.
Is that where our lives are headed? We get output from something that's generated that may or may not be correct, and we copy and paste and go.
Can I ask you, propose an alternative, and you tell me whether that's any better? Stack Overflow?
Exactly what I had in mind. We had it for years. We just didn't call it that.
If you don't know how to do something, right? And AI helps you, it will probably not make it worse than you not knowing how to do something. And before AI, you would either not do it, or you would go to Stack Overflow, copy and paste. The only difference between Stack Overflow and AI is that one is faster than the other.
Which, by the way, means that most models we currently have are trained on answers from Stack Overflow. We're talking about code.
Exactly.
Yeah.
I can never get away from Stack Overflow, is what I'm hearing. The Stack Overflow is always going to be the true way of doing development going forward, because it's been immortalized in a model somewhere.
It makes perfect sense, because models cannot be trained really only on code. So if you say, hey, I have a model that digested every single GitHub repo, code, now I'm talking about code, right? You won't get far. You need some kind of opinion, some kind of ranking, some kind of idea that A is better than B. And you get that through rankings in Stack Overflow. You get that through comments, and so on and so forth, right? So Stack Overflow is more valuable potentially than code itself. GitHub repos, not as a source of knowledge, but as a source of ranking things. Now, how reliable Stack Overflow ranking and comments are, that's a separate discussion, right? But it's better than nothing.
Absolutely. I agree. I think every major AI company has their own army of, I forgot the technical term, but they kind of adjust the answers by the LLM to help it. There's a technical term for that, but they help it, manually helping it make better decisions and better answers. With Stack Overflow, it's open. You can literally see who voted up, who voted down. You can see what they said. With AI, it's hidden from you. You can't really see it.
But isn't that the same thing we're doing with auto-scaling our pods? We can't see what's doing it?
In a way, I think it's not the same, because if you have something like everything with Kubernetes, if it's an application, a controller, whatever it is running in your cluster, you can view the logs, you can see what it's doing, you can see that it'll be collecting something that you already have, right? If you're running Prometheus or whatever other system for collecting metrics and monitoring, you have the information. If you want to make better decisions, it's up to you. If you want to kill it and start something new or build your own, it's yours. That's part of the magic of Kubernetes. It was built in a way to help you extend it and do whatever you want. So in a way, I think that means Kubernetes is one of the most open platforms you can look at and learn from.
Now, we said at the top that you work for Zesty. What does Zesty have that can help us with this?
So I hinted earlier, but basically we're building a platform that has a few components to help you do exactly that. You can right size volumes, which is something you can partially do only upwards. You can't shrink volumes, so we do that. We help you right size containers. And by right sizing, I mean we do both horizontally and vertically. So we'll help you do the VPA's work by making yourself aware of the horizontal scaling so that they don't conflict. So that's another big pain point that we solve. We have a bunch of additional features. We can help you get instances faster. So if you have something like Carpenter that reacts to context, Carpenter is like cluster autoscaler, adds more nodes to your cluster when you have unscheduled pods and they need more hosts. This can take time because it speaks to your cloud provider and launches new instances that in turn needs to download the images, unpack them, yada, yada, yada. This thing takes time, sometimes up to 40, 45 seconds. We have another mechanism that hibernates nodes with the images on them and then lets you have them way quicker, like 15, 20 seconds. So in essence, a platform that packs a bunch of features for right sizing, auto scaling, quicker scale, and connecting to our multidimensional with the time dimension. So we help you even shorten the time in that sense.
Now, Zesty can be found at zesty.co. That's zesty.co. And all of Omer's contact information will be down in the episode description. Omer, thanks for being with us today.
Thank you for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.